If you have ever struggled with PySpark joins, you are not alone. I have been there too. Hello and welcome to my channel. You may already know this. A PySpark join, it could be on a single column or on multiple columns or a join across multiple tables, which can quickly get complicated. If you want to write PySpark joins confidently and avoid common pitfalls, you are in the right place. I have put together a three-part series to share what I have learned about writing PySpark joins. My goal is to make this series a one-stop resource for mastering PySpark joins. There is plenty to explore, so let us dive in. Let us assume we want to join two data frames. The first step is to answer two questions. One, which columns to join the data frames on? Two, which join type to use? Of the two questions, in this part one of the series, we will focus on the join types. Later in part two, we will talk about which columns to join on and how to join them. By the way, if you are already familiar with join types, feel free to jump straight to part 2 of the series. Now, let us take a look at different join types. PySpark supports 7 join types: inner join, left outer, right outer, full outer joins, left semi, left anti joins, cross join. First, we will look at simple illustrations for each join type, showing example inputs and output. Then we will walk through a Databricks notebook. It has working examples based on the data that we used in the illustrations. Let us start by introducing two example data frames: employee data frame and department data frame. We will use these two data frames as input data for our illustrations on the join types. As you can see in the employee data frame, there are 5 rows, and in the department data frame, there are 4 rows. We will join these two data frames on the department ID column. Now, I would like you to take notice of 3 points on the screen. Point 1, there are matched rows between the left data frame and the right data frame. The matched rows were highlighted in green. Point 2, there is an unmatched row in the left data frame. It's highlighted in orange color. It's department ID 504. Couldn't find a match in the department data frame. Point 3, there is an unmatched row in the department data frame. It is highlighted in purple color. It's department ID 525. Couldn't find a match in the employee table. It would be nice if you could remember these 3 points. It can help understand the join types better. Hope it is clear so far. By the way, I quickly wanted to mention a couple of things. One, throughout this discussion, I will use the terms data frames and tables interchangeably. Two, as you may already know, in database terminology, we refer to the first table in a join as the left table and the second one as the right table. Now let us go on to see how each join type behaves. Let us start with inner join. As mentioned earlier, we want to join employee data frame and department data frame on department ID. By definition, inner join returns only those rows that have a matching key between left data frame and right data frame. So in the output of the inner join, you see only the matched rows. Now that we have seen inner join, let us move on to discuss outer joins. Here I am showing the output from left outer join, right outer join, and full outer join side by side. That way, I think it is easier to compare and understand the three join types. So let us go through each of the outputs one by one. Let us start with left outer join. Left outer join returns all the rows from the left table, regardless of a match was found in right table or not. Wherever there was a match found in the right table, those details are returned as well. For the rows in the left table for which there was no match found in the right table, those fields will be populated with null values. Right outer join is the reverse of left outer join. Right outer join returns all the rows from the right table regardless of a match found in the left table. Wherever there was a match found, those details from the left table are also populated. For those rows in the right table for which no match was found in the left table, their null values will be populated. Full outer join is a combination of left outer join and right outer join. All the rows from left table as well as all the rows from the right table are returned by the full outer join. Wherever there was a match found between the left and right tables, those details are populated. And wherever a match couldn't be found in the other table, nulls are populated. Are you with me so far? So that's how outer joins work. Let us see what happens in the case of left semi and left anti joins. Again, even in case of left semi and left anti joins, I am showing the outputs side by side so that it is easy to compare and understand the two join types. Let us first take a look at left semi join. Left semi join returns only the matched rows from the left table. However, it wouldn't return the matching row details from the right table. One thing to note about the left semi-join is there is a similarity between left semi-join and inner join. The similarity is both return matched rows only. But the main difference is inner join returns matched row details from left table as well as right table, whereas left semi-join returns matched rows from left table only. Coming to the left anti-join. Left anti-join returns only unmatched rows from the left table. Okay, that was left semi and left anti-joins. Now, here is where things get interesting. Cross-join handles the situation completely differently. So to explain the cross join, we will use department data frame and location data frame. As you already know, department data frame has 4 rows and the location data frame has 3 rows. Now, when you apply a cross join between the department data frame and the location data frame, cross join returns every department paired with every location. To understand it better, let us take a look at the output of the cross join itself. In this output of the cross join, here you can see department. There are 4 department rows, and each of those department rows is paired with every row in the location data frame. I hope that is clear up to this point. That is everything about the join types. So far, we have looked at the illustrations for each join type. Now, it is time for code walkthrough in the Databricks notebook. So, here is the Databricks notebook. It includes working examples for all the 7 join types. Let us start with the syntax for the join itself. A join takes left data frame, the right data frame, the columns on which we want to join the 2 data frames, and the join type itself. Here is the code to populate the example data frames. We have 3 example data frames: employee data frame, department data frame, and location data frame. The data we are using in these example data frames is exactly same as what we had seen in the illustrations earlier. Coming to the code for the join types itself, I have working examples for all the 7 join types, but to keep things efficient, I will focus on walking you through the inner join in detail. Then we will just skim through the rest and call out the important points. Hope that's fine with you. In this inner join example, for now, let's not bother to understand these 2 lines of code which I just highlighted there. We will cover this in the part 2 of the series. As I am highlighting here in this transformation, we are joining the left data frame with the right data frame on the department ID column by specifying join type as inner. Apart from joining the 2 data frames, as a best practice, we will select only those columns that we are really interested in. That way, I am selecting only a subset of columns from the left data frame and also a subset of columns from the right data frame, rather than selecting every column from both data frames. Now, when you run this query, you would see the results which contain only the matching rows between the left data frame and the right data frame. And the result contains the selected columns from the left data frame as well as the selected columns from the right data frame. For the left outer, right outer, and full outer joins, the syntax is very similar to that of inner join, except that the join type is different. Obviously, in case of left outer join, the join type that you specify is left outer, but for that one, everything else is very similar to that of inner join. Similarly, in case of right outer join, you will be specifying this join type as right outer. So is the case with full outer join. You would just specify full outer join. Moving on to the left semi join and left anti join. Again, the syntax is very similar to that of inner join, except for a couple of points. Obviously, the join type, we need to specify it as appropriate to left semi join or left anti join. Then one other difference compared to inner join is that in case of left semi and left anti joins, while accessing the columns, you could access only the columns on the left data frame, and you should not try to access the columns in the right data frame. If you attempt to query the columns in the right data frame, either you may get the incorrect results or it could throw an exception. Finally, coming to the cross join. In terms of the syntax, 2 points to note here. One is, in case of cross join, you specify this join condition as none instead of specifying the columns to join on. And secondly, the join type will be cross. Aside from this, the syntax is very similar to that of inner join. Otherwise, I would like to call out an important point in regard to cross join. In production, use cross joins carefully because the output size can grow very quickly. For example, here in our working examples, we use the department data frame, which has 4 rows, and the location data frame, which has 3 rows. When we applied cross join between the department data frame and the location data frame, it resulted in 12 rows, which is a Cartesian product of 4 times 3. If such is the case, can you imagine in production if you were to join a 10 million row data frame with a very small 10 row data frame, it could result in an output of 100 million rows. Hope it is clear so far. All right, that is it about the code walkthrough of the working examples. At this stage, if you ask me, which of these join types are commonly used, I would say the choice of join type depends on the functional requirements. Having said that, inner join and left outer join are the frequently used join types, whereas left semi join and left anti join could be occasionally used. The rest of the join types are rarely used, but good to know what they are. All right, that's it for today's session. If you found this helpful, don't forget to hit the like button and subscribe to my channel for more content like this. Now, in this part 1, we have only scratched the surface. There is a lot more to uncover. In part 2, we will dive deeper into PySpark joins beyond the basics. So make sure to join me in the next video. Together, we will learn to write PySpark joins like a pro. Thank you for watching.